All right, so we're go ahead and doing lesson 16 today. Trying to finally figure out how to do these videos 9 weeks in, 8 weeks in.
It,
Um,
it looks off error for me.
what's up?
It doesn't look that you're recording right now. Oh, there we go.
Yeah,
Now,
I'm recording.
never mind.
We're good. All right, so we're gonna go ahead and start with question 3. Some of these are just kind of basic terms that are pulled off the wiki. Like in a pie chart, why are the slices? Why are the slices or sectors different sizes? I got each slice represents a category, and the area each slice represents the portion of the total occupied in that by the category.
Yeah, and that's just because like every side of the pie is just gonna represent a number
Mm-hmm.
that is in an Excel sheet. So that's basically why.
All right, perfect. Number 4.
So the question is how are bar charts and parental chart related? And the only difference between a bar chart and a parental chart is that the bar is a parental chart are order larger to smaller, going from left to right.
Yeah,
And
again,
then just to say,
very simple.
yeah.
Same with the next one. Conclude that I believe it's the true p is normally distributed if np is greater than 10 and n minus p is greater than, or n 1 minus p is greater than 10. Is
Brilliant.
the true portion or the sample portion? Then I got that it was the true portion.
Perfect, that's true. And for six, what is n? It's just basically it's just the sample size.
Yeah, it's in the
It's
sample size, just like in any other of the homeworks we've gone through. It just means the same thing that we've been going through.
yep.
Okay, if p equals 1/4, 1/4, what is the smallest n that satisfies the requirement? So if we wanted to satisfy the requirement, it has to be more than 10. So when you look at it, what's more than 10? What can break down into 4 would be 12.
For that I got 40.
40.
Yep.
Because what you can do is you can break it down even to a smaller number, just because you can break 12 down into 4.
Uh-huh.
You know what I'm saying?
Yeah.
I'm asking for the smallest.
Oh, okay. Got it.
That's the first number after 10. That's going to equal that can break down into 4. Can be simplified into 4.
So it's gonna be 12.
Yeah, at least that's the way I understood it. You know what I mean?
Okay.
That's for the smallest number that satisfies the requirement. And the requirement is that n has to be greater than 10. So what would be the number right after 10? That equals that can be simplified to 4. It would be 12.
Okay.
You know what I'm saying?
Yep. Okay, and then for number 8, we gotta use the information to answer the question 8 and 9. So n is 24 and p is 0.04. So what does it mean? P basically, and the answer is 0.4.
0.4.
Yep.
And then, so for this one, so we had to use the standard deviation of p equals the square root of p times 1 minus n divided by n, or excuse me, 1 minus p divided by n. What we had discussed when we were talking about that you had 0.1, or you had 0.1 and I had 0.01. So when you do this problem, you're gonna put square root of 0.4 times 1 minus 0.4 divided by n. So this is the way that problem is going to be set up. Let me see where it is. It's right here. See what I'm talking about?
Yep.
So it's going to be like that. So if you put that into your calculator, so 0.4 times.
And remember the square root, right?
Yeah, and then you also got to make sure you square it at the end.
Okay.
So then you got to make sure you do the entire formula inside the square, inside the square root, and then you find the square root of it all. So if you do 0.4 times 1 minus 0.4 equals 0.24. Did you get that?
I don't have the calculation with me, but I think so. I have 2 point something, so I don't remember.
So it's the calculation I got was 2.4, and then you divide that by the n, which is 24. Oh, and then this is probably, yeah, that's where I'm wrong. So then you find the square root of the point. Yeah, you're right. So then you find the square root of it all, and you get 0.1. So yeah, you were right.
Okay. And so now we got for number 10. This is basically saying what is the p-value, but now with the new information, we got the n is 100 and p is 0.3. So the p-value for this one is 0.35.
Yeah, because they want to know what will happen for or what's the p for 35 of 100.
Yeah.
All right, and then the standard deviation, we're going to do the same formula as before, which actually came out to be a very small number, and I wasn't sure if I got it right. So you're going to do the 0.3 times 1 minus 0.3 divided by the n, which is 100. And then you find the square root of that, which comes to 0.046.
0.046. You say 0.046, right?
Yeah.
Yeah, okay. And then for the z-score for that is going to be 1.087.
So the z-score?
The z-score will be 1.087.
So the way you're going to find the z-score, it's, okay, I see what I was doing wrong there. Okay, I kept forgetting to find the square root of things, so now that I figured that out, so then with this one, just to find the z-score, we're going to do the 0.35p minus 0.3 divided by that 1.0, divided by the 0.046, right? To find that z-score, which is going to be which is going to be change it to be in the 0.1. Okay, perfect. The 0.1 or 1.087.
And then the oh no, you're next. Sorry.
Yeah. So then, what you want to go ahead and do is that it's asking you what is the probability that Brittany gets at least 35 hits in her next 100 at-bats. So you're going to go ahead and put that into the normal probability applet. So you're going to put 1.087 in there. And it's asking what the probability of that is. So you're going to shade it on the right side, which is going to be 1.39.
No, it's 1.39, or I think it's a 0.139.
Yeah, that's what I mean. Sorry, 0.139. Cool.
Okay, for the next one, they give you it's like a sample of for a political candidate, and they give you like the N number, which is 200 people, and the P value is 0.52. And so they want to determine the probability that the result of the survey will suggest that the candidate is losing the elections, getting less than 50% of the votes. What is the standard deviation for that? Is going to be 0.011 because we're gonna use the same calculations we used before.
Yeah. So it's going to be the 0.52 times 1 minus 0.52 divided by the 2,000, and then you find the square root of that, which equals that 0.011.
Perfect.
All right, and then to find the z-score of that, we're going to go ahead and let's see. So this is the one where we started to have some issues, right? We're kind of confused.
Yep.
So it's saying if the true portion of people support the political candidate equals 0.52, and if n is 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of the votes. What is the standard deviation? So we just found that out. And then finding the z-score, I think what we're going to do here is we're trying to find what's less than 50%, or what's less than 50%. So that's what the that first key is going to be. Is going to be 0.5, and then we'll subtract that from 0.52. You get what I'm saying?
Yep.
And then when we shade the applet, it's going to be shaded to the left.
Are you serious?
Okay.
So it's going to be negative 0.2. So when you do the equation, it's going to be the 0.5 minus 0.5 or 0.52 divided by that standard deviation, 0.011, which comes out to negative 1.818.
So it's gonna be negative 1.818.
Yeah.
Okay.
So that's when you do the equation. You put the equation in there, and then you do the 0.5 minus 5.2. 0.5, or excuse me, 0.52 comes out to negative negative 0.02, and then you divide that by the standard deviation, and that comes out to be the negative 1.818.
Okay, and I'm not quite sure for this one, but the probability to compute using the normal probability applet is gonna be P that C is less than C for number 16.
Is gonna be. I think it's gonna be P is Z is greater than no.
Oh, great. Oh, yeah, because it's the other side, right?
Yeah.
Okay.
So then when we put this into the applet, the negative 1.18,
Oh yeah, I was wrong. Sorry.
and we shade it to the left, you get 0.035.
Good. Good.
When you shade it to the left.
Miss again, please.
So it says, what is the probability that surveys will show that the candidate is losing even though P equals 0.52? And then when you put that in the applet, you put that z-score in the applet, and you shade it to the left, it'll be 0.035.
Okay, 0.035, right?
That's what I got. Is that what you got?
Yep, let me see.
Good.
Ouch. Because he probably applet by mistake. Wait.
Oh, yeah. Go take it. Oh, man. Oh, come
Hey,
on.
how?
Easy. Hey, now you're off that up on the floor.
So you put point 52, right?
Sorry?
What did we put in the probability applet in the area?
The probability or in the probability applet, you're gonna put the z-score that we found.
Wait. Yeah.
And then you shade it to the left.
To the left?
Yeah, you're gonna shade it to the left because it's the probability that he's gonna lose.
I got another number.
What number did you get?
Okay. Wait.
Make sure just the left is shaded. Like the very far left. Because remember, the z-score is negative 1.815, or excuse me, negative 1.818.
Nearly 1.818.
Yeah, that's the z-score. And then we shade everything to the left.
It's not working. Wait. No, not. Can you show me yours?
How? What do you mean?
Like in the screen? Cause my you're using the normal probability applet, right?
Yeah.
Because I'm typing the numbers here, and it's not moving by himself.
It's not moving by itself. So put the in the z-score on the bottom, on the negative sign, put negative 1.818, and then hit enter.
And then I just select the left side or the right one?
You select the left side.
Okay, I got 0.0345.
Yep. So then you're gonna round it off at 3 decimal places,
Okay.
which will be 0.035.
There we go. Sorry, that was doing the wrong one.
Yeah, that's no problem.
Okay. Okay, perfect.
Yeah. All right. So I think
We got 2 wrongs.
which ones?
16 and 15.
16 and 15.
Yeah.
But 17 was right.
Yep. That's weird. Because the z-score supposedly was wrong, but I don't know why. What's the z-score again?
The z-score we put in is negative 1.81. So I have to imagine that if it's the same, but we got 17 right though, right?
Yep.
So that means that the z-score would have had to have been positive.
Oh. Okay, and then the probability just, as I told you, I think it was the left. C is less than C. So it's not greater than that, it's less than.
Okay.
So you just make those changes.
No, that wasn't. That's crazy. We got a wrong z-score, but we got a correct. We got a wrong z-score, but we got a correct. We got the right probability.
What the z-score do you put is minus?
1, 2, 3 decimals. I don't know how that would have happened.
I don't know. We probably should email him, or if he will be watching this video, you can take a look of it.
Yeah, I'll make sure. Like he says to leave questions in the in the comments. So I'll go ahead and make sure I leave a question for him at least, so that he can read that. But yeah, that was really strange because we got the right probability, but I don't know how our z-score could be wrong, even if it's negative or positive. You know what I mean?
Yeah, true.
That's really strange. So we'll have to talk to him about that. But let's talk about the final project.
Okay.
So it says
Well, for the video, you can just the video will you need to pause. We don't need to talk about it, right?
I don't know. We can stop it if you'd like. Either way.
Yeah, we can stop it.
All right, let me stop the broadcast here real quick.